Section 2.7, transformation of functions. We're going to talk about transformations of functions, moving it right, moving it left, moving it up, moving it down, rotating it around an axis. We're going to compress it vertically. We're going to compress it horizontally. We're going to stretch it vertically. We're going to stretch it horizontally. And we are going to use our graphs that I told you you need to know, like y equals x squared, y is equal to the square root of x, y is equal to the absolute value of x. Those functions that I gave you in the previous section, or sections, you need to know those basic functions. Because we're going to use those and we're going to use transformations to graph them. So here is a graph. And you don't need to know that this graph is f of x is equal to sine of 2 pi x over 3. You don't need to know that. But if you want to put in your calculator, type it in your calculator, and this is what you'll get. Okay? Stretching and shrinking a graph vertically, or stretching and compressing a graph vertically, if you want to use the word compressing instead of shrinking. That means up and down. We're going to stretch it or compress it. If I take that function and I multiply it by some number, so I'm going to multiply it by some number, like say 2. What that'll happen is it will stretch it vertically. So instead of this being a high of 1, it goes up to a high of 2. So instead of the relative maximum point being 1, the relative maximum will occur when y is 2. Likewise, the relative minimum, instead of that minimum being down at -1, it'll be down at -2. So if I have something like 2 sine, 2 in front of it, that will stretch it vertically. If I have a 1/2 in front of there, it compresses it vertically. Okay? So compress it. Instead of that being to 1 and -1, it's now to 1/2 and -1/2. So it compresses it. Notice from right to left, it did not change. It still has the same period. So it takes this long to go through one cycle before it starts repeating itself. That's your period. So a number multiplied in front, if it's greater than 1, will stretch it vertically. A number multiplied in front between 0 and 1 will compress it vertically. And here are the graphs here. The same graphs. And like I said before, look at the graphs right to left. They don't change at all. The only thing it does is change the amplitude, the height. And like I said, when it's greater than 1, it would stretch it vertically. When it's less than 1 and greater than 0, so between 0 and 1, it shrinks it vertically. But right and left does not change. These graphs, the right and left will change. So instead of taking your sine graph that you have, this was the sine of 2 pi x over 3, okay? So I told you it was, stay right over here, sine of 2 pi x over 3. That's what that blue graph is. Instead of that, I am going to multiply it by some number, the x by some number, so my x is going to be multiplied by 1/2. If I put another 1/2 in there, that will stretch it horizontally from right to left. If instead of a 1/2, I put like the number 2, that will compress it horizontally. Okay? So if the number is between 0 and 1 and I'm multiplying it, it's a horizontal stretch. If it's greater than 1, it's a compression. It's shrinking. And some people, this doesn't make sense to them, but think of whatever you have in there. I have f of x. Now I have f of 1/2 x. let's say this x right here is 1. So I have f of 1. The only way to get f of 1 here is if x were 2, I'd have 2 times a half, which is 1. So then I'd have f of 1 also. So that's why this x stretches from 1 to 2. So it's moving out. Instead of being 1, it's at 2 now. So that's why if you do the half in there, or something between 0 and 1, it's a stretch. If you do a number greater than 1, it's a compression. Okay? And the reason is, if I have f of x and f of 2x, let's say this x, again, is 1. The only way to get 1 here is if x is a half. 2 times 1 half is 1. So now my x went from 1 to 1 half. So it shrunk horizontally. So that's why it's a compression. And there's the graph right there. Same graphs, like I said, stretched and shrunk horizontally, but the high points and low points did not change. The blue graph was my original graph. It took 3 units to go through one cycle before it started repeating. This is 3 units, 3 units. Notice the red one takes 6 units to go through one cycle, and the green one takes 1.5 units to go through a cycle. And that's what I said here. I said the 6 units instead of the 3 for the red graph. The blue graph, it takes 1.5 units to go through a cycle. So summary of the previous pages, if I multiply the outside number, so like I have a 5 in front of the sign, that would stretch it. If I have a 1/5 in front of the sign, that would compress it vertically. So it's changing my y. It's not changing the x at all. X stays the same. My new y would be c times y. So instead of 1, if there's a 5 in front of the sign, if I use the old graph, it would go up to 5. Okay? If there's a number inside multiplying the x by, that's where I said the height stays the same, so my y stays the same. My y is still the same. My x changes. And my new x would be x divided by 3. The one example where c was a half, x divided by a half is the same thing as 2x. Okay? So it's my x is stretching out. Okay? Next, translating graphs. Going to move the graphs, right or left. The blue graph there is y is equal to x squared, and you should know how to graph that. If you look at this graph here, y minus 2 is equal to the quantity x minus 1 squared. It does have y equals x squared in it. Y is equal to x, and there's my squared. It just has a minus 2 with the y and a minus 1 with the x. So you would start with your base function y is equal to x squared. If you have some number with the x, that's either a right or left movement. And on this one, since it's minus 1, it's right 1. If you can put the number with the y like this is either up or down movement, and that is up 2. So if you have y minus k is equal to f of x minus h, the h is the right and left movement, the k is the up and down movement. If you can put it with a variable, minus 1 would be right 1. If this were plus 1, it would be left 1. Minus 2 would be up 2. Plus 2 would be down 2. So now I take my y equals x squared. Here's a point 0, 0. Go up 2 over 1. Here's a point 1, 1. Up 2 over 1. Here's a point negative 1, 1 that's on that graph. Up 2 over 1. I have 3 points on the graph. Red and blue graphs, they're the exact same shape, the exact same size. The only difference is it is shifted. And the red graph is shifted 1 unit to the right, 2 units up. Let's translate the graph. Y is equal to the absolute value. Let's translate that into y plus 1 is equal to the absolute value of x plus 2. So the blue graph is y is equal to absolute value of x. You should know how to graph that. Plus 1 is up or down movement. And it would be down 1. Plus 2. 2 is right or left movement with the x. The plus 2 would be left 2. So now take every point. So here's 0, 0. Go left 2, down 1. That point here, left 2, down 1. This point here, left 2, down 1. And then here's my new graph. Okay? Same shape, same size. The red graph is just 2 units to the left, 1 unit down. Okay? So notice, plus 1 made it go down. The minus 1 would make it go up. Plus 2 makes it go left here. A minus 2 would make it go right there. Now I'm going to combine reflections with the translations. So I'm going to reflect. Remember when we were doing reflections before, when we were talking about symmetry. Remember, if I did something like this, that was my x going from positive to negative. So this is around the y-axis. X going positive, because here's x positive, x negative. So this is around y. Okay? Remember, if I did something like this, if I had an f of x and instead I went negative f of x, this is my y changing signs. So my y would go from positive to y being negative. So this is around the x-axis. Okay? So now I have y minus 1 is equal to negative, the absolute value of x plus 1. Start with your base function. Y is equal to the absolute value of x. So here's where I start. And you better know that this is what it looks like. Okay? When you have a reflection and translations combined, you reflect first, always. Because if not, you could get the wrong answer. So reflect first. So I'm taking that y is equal to absolute value of x, and I want to go to this equation here. There is my reflection. So the next graph I'm going to think about is y is equal to negative the absolute value of x. So I just say y is equal to the negative absolute value of x. My y is going from positive to negative, so that's a rotation around the x-axis. So it's this graph right here. And the very last step, I'm going to move it. So the y minus 1 is equal to negative the absolute value of x plus 1. Remember that minus 1 would be up 1. So this would be up 1. And x plus 1, with an x it's right and left movement. The plus 1 would be left 1. So from this point, now I'm at the black one, I would go left 1 and up 1. So this point would be here. This point, left 1, up 1. This point, left 1, up 1. And it'd end up to be this graph right here. So make sure you can distinguish between your graphs on this page, because if you printed it on a black and white printer, you just see a lot of black lines. Okay? Notice if I would not have reflected first, if I would have moved this first, if I would have taken this blue graph and moved it up one and left one, I would have a V right here, and if I reflected it, I'd have a V down here, which is not the same, which is not right, correct. In summary, here my Y is changing signs, so it's a reflection in the x-axis. Here my X is changing signs, so it's a reflection in the y-axis. These are vertically changing. If C is greater than 1, it stretches it vertically. If C is between 0 and 1, it shrinks it vertically. With the X, it's horizontally changing it. Greater than 1 shrinks it horizontally. 0 and 1, between 0 and 1 stretches it horizontally. And Y minus K is equal to F of X minus H. Right-left movement with the X, up-down movement with the Y. Homework, 1 through 7 all, 9 through 19 odd, 21 through 32 all, 33 through 55 odd, 63 through 89 odd.